All right. So now we're going to look at combining like terms and looking at this process so we can figure out why is it important to combine like terms before solving an equation. So let's start by defining some of our vocabulary words here. The sidebar question says, what is the difference between a term and a coefficient? So we'll look at each of those separately. Okay. A term is a number, which is generally called a constant, a variable, or the product of a number and a variable. So a term could be any of these things: a number, a variable, or the product of a number and a variable. A coefficient is a number that is multiplied by a variable. And I'm going to show you some examples. It's a little easier to understand the difference between the two when you can see them. Okay, so I have some values here. We have 6, x, 5b, 5y to the second power. Each of these are considered terms. So all 4 of these are a different type of term. We have a number, a variable, or the product of a number and a variable. Okay? And then coefficients are what I have highlighted here, are these 5s that are in front of those variables here. It's showing that we're multiplying the number times the variable. So those are your coefficients. Okay. And I want to remind you that when you see x, the variable x, that's the same as 1x. So we don't have to write a 1 as a coefficient there because it's understood that if you just have an x, you have 1x. Okay? So our next question that we want to look at is, what is the difference between like and unlike terms? So if you think about that, things that are alike or like are similar. Things that are unlike are different. And so we want to know, or we have to know, that like terms must have the same variable and the same power or exponent. Coefficients do not have to be the same when dealing with like terms. And constants, or those numbers, are also considered like terms. Okay, and so let's look at some examples here of like terms and unlike terms. So you'll notice here for my like terms I have 3x plus 2x. So here's an expression that before we were trying to solve it, or if we were given 3x plus 2x equals, say, 15, before we can solve that, we would need to combine the like terms. We don't want to solve for x twice. When I combine these two terms, I'm going to get 5x. We have w minus 4w. When I combine those like terms, we would get negative 3w. And then we have 5 and 1 4/10. Okay, when I combine these like terms, I get 6 4/10. Again, so like terms have something in common. In this case, the x, the variable, is what they have in common. The coefficients can be different, but I can combine those. Again, the variables are the same. Here, these numbers are both rational, and so I can combine rational numbers. Regardless that one's a whole number and one's a decimal, you can still combine them. Unlike terms, if you look here, notice that I have two different exponents. I have x to the second power, and then we have x by itself. So I cannot combine these terms because they have different exponents. Look at this expression, 6a minus 6b. These two cannot be combined because they have different variables. Okay? And finally, I have 3 2/10 plus x. These two terms cannot be combined because we have a constant or number here. and a variable. Okay, so this is very, very, you might consider this to be kind of a basic topic, but we need to make sure we understand the difference before we continue to move on here. So let's look at why it's important. I have a few sample problems here. I want you to write those down. So I'm just going to zoom in a little bit. The first three here are showing where we're simplifying each expression. So we're not solving yet, right? We're just combining like terms if possible. Okay, this would be a good place to pause the video, try these three out, and then unpause it and see if we have the correct answers. You'll notice that 2y and 5y both have the same variable, different coefficients. It's okay to have a different coefficient. So if I were combining these like terms, I would have 7y. In example number 2, we have 5b minus 2b. Again, we have the same variable, different coefficients, but we can combine these. Now the term combining like terms, sometimes we have to do the operation of subtracting. So you'll use the operation that is provided for you or that's in the problem, but it's still considered you're simplifying each expression, or in some cases we'll hear that term again, combining like terms. So 5b minus 2b is 3b. Other times you might have a longer expression like this one. We have 2x plus 9 plus 5x minus 1. And what we want to do here is combine the terms that are the same. So I'm going to be combining 2x and 5x, and I'm also going to combine the 9 and the 1. Okay, so before I just combine these, I'm going to go ahead and rewrite them so that the like terms are side by side. We have 2x plus 5x plus 9 minus 1. This might be a little easier to see this now. Our like terms are here together, so we have 2x plus 5x, which is 7x. And we have 9 minus 1, so I'm going to bring this addition sign down, but 9 minus 1 is 8. So there we have simplified this expression by combining like terms. And then sometimes you'll have to combine like terms and then solve an equation. So I have two examples here. Make this a little darker so you can see it. Okay. The first example says 2r minus r equals 10. The second example says 5x plus 4x equals 81. So I'd like you to try to first combine like terms and then solve the equation using inverse operations. Okay, pause that video, try these two, and then come back and play it again when you're ready. All right, so combining these terms, I have two r's and I take away one r, which means I have r equals 10. That was pretty easy because there isn't an extra step here. I want to go ahead and check the solution. So anytime we're solving equations, I want you to use substitution to check that. So let's go ahead and put in here 2. The original problem said 2r minus r equals 10. So if I have 2 times r, which is 10, minus r, which is also 10. Let's see if that equals 10. What is 2 times 10? 20. And what is 20 minus 10? 10. Therefore, 10 does equal 10. That is the correct solution. Okay, let's try this second one here. Now we have 5x plus 4x. So we're going to combine these terms here. I have 9x equals 81. Now in order to solve this problem, I have to do something else. Remember, we always want to get the variable by itself, and right now there's a 9 that is being multiplied by it. So since this is showing multiplication, the inverse would be division. So let's divide both sides by 9. The 9's here will cancel out, and I'm going to be left with x equals, and what is 81 divided by 9? 9. Okay, let's substitute for x and see if this is correct. Now you could substitute after you combine like terms. So we combine this to say 9x equals 81. So we have 9 times 9. Does that equal 81? Yes, it does. Okay. We could also put it here. We could have 5 times 9 plus 4 times 9, and we'll see if that equals 81. What is 5 times 9? 45. And what is 4 times 9? 36. When I add these two values, 45 plus 36 does give me 81. Therefore, our solution checks out.